Let's take a little bit of time here and talk about scalars and vectors, and we're going to treat this really briefly, but it's something that's going to be really important this year. So if it's a topic that you're not super familiar with, maybe you're not as comfortable with it from your previous math classes, please ask and please spend some time practicing it, because it's better to put in the time now and not be as stuck on it later in the year. So jumping into that, the first thing we want to talk about are scalars. And so scalars are quantities that have magnitude or amount only. And the differentiation between magnitude and what else you can have will make sense a little bit later. So for example, a time or an age would be scalars, right? They have an amount, like the amount of time that has passed, how old something is. A length is a scalar, how long something is, because it just has an amount, right? The mass of an object is a scalar because you know how much mass, how much stuff is there. So those are all examples of scalars. We also have a quantity known as vectors, and a vector is something with magnitude, just like a scalar, and direction. So there's something where it makes sense to ask in which direction, or which way, or something like that. If you ask which way for a scalar, that doesn't make sense. Like if someone says, oh, I'm 10 years old, and you say, which way, that doesn't make sense. But if someone says, I've traveled 15 meters, I've moved a certain distance, you can say which way. Like, did you move 15 meters up, down, left, right, etc. So examples of this would be something like I just mentioned, displacement. So this is different than a length. This is actually like comparing 2 points. So if you move from this point to this point, that displacement is a vector. Velocity is a vector. So how fast you're traveling and which direction. There is a scalar quantity related to velocity, speed, and that's just how fast. You don't need to necessarily memorize these, but I do want you to have the idea of the differences so that as we talk about a lot of these going forward, you'll be able to kind of distinguish them. We also have something like acceleration or forces. So these are all examples of vectors. They have an amount and a direction. Now, these can be broken into components using rules with right triangles. So if I have a vector like this, so this is my vector that we'll call A, well, I can break that up into a piece pointed in the x direction, and we call that A sub x, and there's a piece in the y direction that we'll call A sub y. So we use trigonometry to do this. If you're familiar with that, great. If not, you'll probably need to go back and review or talk to me about it. So if this angle is theta, we know that AY will be A sine theta, and AX will be A cosine theta. And then we can combine AX and AY back to A, because we know that A squared equals AX squared plus AY squared, and all the other trigonometry that can apply for right triangles. So these AX and AY are components. They're basically the pieces in kind of the two different directions, these two perpendicular directions, the X direction and the Y direction. And most of what we'll do in physics with vectors is breaking them into components, doing math with those components, combining them back together. In general, with vector addition, the way that we add two vectors is connect the head to the tail and then draw a line from the start to the finish. So if I have something like vector A, and then I have another vector, vector B, to find the sum, I take that vector A and I draw it, just like this. I draw vector B next to it, just like this. And then I start from where I started and go all the way to the end. And this vector will be A plus b. And so we could do this again and again with multiple vectors. But more commonly in physics, we're going to add components. So if I take those same vectors, I have this vector A, and I have this vector B. And so what I can do is break this vector A into an AX component and an AY component. And the B, which are a very shallow one, so it's a little hard to see, but it has a BX and a BY. And then my final vector is just going to be the AX component plus the, sorry, it should be a bit longer, plus the BX component. Then I can add the AY component and the BY component. And what's nice about this is this math is easy, right? Because this is all in the X direction, this is all in the Y, so I can just add AX plus BX, whatever these numbers are, I can just add those together. I can add the Y's together and I get some final triangle that's going to be AX plus BX and AY plus BY, and then it's really easy to use the Pythagorean theorem to solve for the magnitude of the final length. So again, we're going through this real quick. If you need to review it, let me know and I'll kind of give you some resources or talk through it with you, but this is just the real quick run through to hopefully remind people that have taken it before, or to point out what's going to be key if you need to do some self-studying here. Vector subtraction is the same idea as addition, but we just multiply the subtracted vector by -1 and add it. So if I want to take those same vectors of A, but then I want to subtract B, well, that's going to be the same. A minus B is the same as A plus -B. And if I want to make a vector negative, I just turn it in the opposite direction. So that will end up giving me A plus a -B. Should be something like this. It's not perfect, but that gives me this vector here, which is A minus B. If I want to do multiplication, there are ways to multiply vectors that we'll probably mention at some point, but we're just going to worry about multiplying a scalar with a vector. So all that you do is just make the vector that many times longer, or that much, the magnitude increases that much. So if I do 2 times A or 3 times A, and my A is this vector here, well, 2A would just be put 1A and then put a second, right? Just like when you first learned multiplication, it's just a bunch of A's added together, 2 A's added together, or 3 A's added together, right? So this here is 2A, and this here is 3A. So that's the basic idea. Let me know what questions you have, and a big part of this that's going to be helpful is just jumping in and practicing.